Yeah, I'm going here to show how to use the ESP8266 SDK, integrating external components. It's a little bit tricky, but it's only actually first time it is a little bit tricky, because then it is a question about reusing the makefile, at least. Now, let's have a look what's actually in the packet. This library has all our sensors I had with me yesterday. The ESP-IDF-lib is for the ESP8266 and the ESP32. That's quite good. And if we open it, then we can see examples and we can see the components. And the components is actually standard C files, whereas a C and a header file. And what I want to show here is how to make an example project using the BMP188, and the example file is in the folder here. In the main there is an main.c containing the program for fetching data from the pressure sensor. So first of all, keep all the examples in the example directory. Instead, make a copy out from that folder, and the way to do it is to use an copy, which is here copy dash R means including the folder name, and the folder name here is that one. So we copy the contents into a folder out here at this position, and so you can see it's quite easy to just change to another sensor. It's a question about doing this statement and change the name of the directory with the example in. And then there is a detail here, space and a point, which is the same as take what is inside this folder and bring it into the folder out here. So if we run that statement, then we will have it here. When we do the listing, you can see we have got it here. And if we then go down insert BMP180, then we can see what's inside. It is the makefile, which we need to modify to point to the components library with the C file and header files in, and then we have the main folder with the main file in. To start out, we must have the makefile modified, and I have already made a project for 280, so I'm a little bit lazy now. I will just take the file from the BMP 280 and copy it. So Control C here, and then overwrite the default one, replace, and then I will open it here and adjust a little thing, because now I have to point to the component 180 instead of 280, so 180. And then, as it is an ESP8266, then we need actually also to add the last path here to a library called ESP-IDF-lib helpers. And we need to also to include the I2C device, which is found here, as this library refers to that one. and the other one is the default one. Of course, it would be a good idea to make a change here as well, so it fits the folder here. And then we save it. And the first step here is to make menu config to set up different parameters in a little GUI here. And the SDK configuration points to the compiler toolchain. And we have used the Expressive's guide for setting it up, so we don't need to go in here to exit a given selection. We go to exit, then we can look on other opportunities. Bootloader, we should not do anything there, but we need to pick the correct serial port for the device, and we need to change. We can change the speed of the SPI here to 80, and then we need to choose the correct flash size. If we choose a wrong flash size, keep the 2 mega, then it will not be appropriately for the device, the Husai board, which has a 4 megabyte flash. So we just choose it, and then we push enter, and then you can see it takes effect. And that's what we need to do in here. Then we go to exit. Then we should also configure a timeout component for the I2C, and that is done in the component config. And if we open it up now, then we cannot find, we will find the I2C here. And here we have to select it, and then it is the time parameter. It is 1 second for a timeout, and this parameter is used in the C file belonging to the device. So we need to go in here and choose it, and then we can say exit. But before we exit, then you should be aware about also the Wi-Fi. You need to perhaps go in here to set parameters, and later on when we deal with MQTT, we need also to go in and do something here. If we open up, we can see what it offers. It offers nothing actually. Let's see here what we jump. MQTT select. Yeah, it was wrong actually. It is meant for the IBM MQTT. So that has to do with their server. So the MQTT library can perhaps not be used in our case directly. Exit. And then you can see actually you can also add a new library, so a new set of C and header files. Now, let's get out here, and we save it, say OK, exit, and the Flasher config, we have still that. We need to save, yes, exit, and then one time more exit, and one time more exit, then we get the start of the a script for making. So then we can do make flash, and then we can even call the monitor afterwards. So if we succeed, then the monitor will start out, so we can watch the output in a terminal. So monitor, and now it will compile all the firmware for the ESP, and if any faults in the main file or in library files, then we will get it out here, and warnings means you just accept it, but errors means you need to go back and correct. And the whole RTOS system is actually built here. So quite a lot happens, as you can see. Yeah, it takes a while. And then the last thing is here, it compiles well, so we have actually created the flash binary file now, but it is not able to connect, as I need to it's this one. Now it actually gets up. So this one should be I check one time more, and here you can see it is there. So now I have I have to say make flash, then it will also program it. We do it one time more, but now it's getting fast because we have compiled it. So here you can see it is writing the binary file into the flash. And on the Husai board you should be able to see and blue LED blinking. Yes. And then we can call the monitor. So make monitor. And then I have to push the button in the center of the Husai board to reset it, to start the program. And here we can see that it fits the temperature and the pressure in megapascal. I wonder about the size of the pressure, but the temperature is correct. And then if I want to stop it, then I say Control Alt and then the squared brackets to pointing to the left, and then it stops. That is the procedure using all the examples actually. So first make a copy, and then do a correction of the path for the given components in the make file, and then you do a make flash connect. You do a make menu config, and then you do a make flash, and then last make monitor, and push the button, reset button, and then it will start the program. That should be all for now.